Hey, alright, today you will cover similar triangles. You will identify similar triangles and use them to solve problems. We will focus more on the identifying similar triangles and how do we identify similarity, and then we'll look at a couple, maybe one or two examples about solving, and then maybe we'll try to talk about that more, the solving part, in class. Anyways, so what are we talking about here? We're talking about why is this important? Well, similarity is very important because it allows us to establish proportional relationships, and that's why we can do things like, here's a blueprint, let me build a house. They are similar because they're the same shapes and stuff like that. So, I want to try this. Alright, so let's do this. Okay, so look, here I've got two similar, let's try this again. So here I have two similar triangles, and look, no matter what the size this is, because this is just fun to do this, okay, one more time. Okay, they're still going to retain certain properties. And so what are those properties that we can talk about? Well, they should still have like same angles that were equal, no matter though they're different sizes. I can make these bigger, and you can see there's the angles are still should be pretty much the same, especially considering I copied this. But you kind of get the idea. Anyways, so there's that. But how do I determine this? How do I see this? Well, I'm glad you asked. There is a postulate that's called the angle-angle similarity. If two angles on one triangle are congruent to two angles of another triangle, then the triangles are similar. Again, all similar means is that they are proportional. That means we can usually set up some type of cross-multiplication problem to figure something out. Or they are, say, based on a scale factor, one multiplies to get you the other. That type of thing. Okay, so in this example here, and I'll back this up a bit. Because I can say here that angle A, if I say angle A is congruent to angle F, and angle B is congruent to angle G, and I only need two angles congruent, then I can say by the angle similarity that angle ABC is similar to FGH. Now notice how I try to line that up. A with F, B with G, H with C, or C with H. Okay, so here's an example. Are these two similar? Are they similar? Okay, so at first glance you go, there's a 57 and a 57, so those two are the same. But, and I say, but 48 and 75, they're not similar. And y'all could be lazy and say, that's it, nope, they're not similar. But wait, what happens if I add 57 and 48? I get 105. And again, all triangles add up to 180, so if I subtract 180 by 105, oh my goodness gracious, I get 75. Okay, well that becomes interesting because now I have two angles. I can say angle L and angle M are congruent, angle K and angle P are congruent. Just based on that, I should be able to say these two triangles are similar. But, hey, let's try the other one. 57 plus 75 is 132. Subtract that from 180 and you get 48. Oh my goodness, the angles are congruent. So, based on this, then I can say by the angle-angle similarity, triangle LJK is going to be similar to triangle MQP. Now notice how I try to make sure like L and angle M are the same, so I try to match those up. Angle J and angle Q have the same measure, so I try to match those up. Angle K and angle P have the same measure, I try to match those up. Well, what about something like this? Ooh, I jumped ahead of there. Alright, so I have this one. Is this one going to be? Well, I can automatically say that both angle S's are congruent because one's opposite the other. Now, because these two are, say, parallel, I can say opposite. When you have parallel, that means opposite interiors should be congruent. So that would be, in this case, on two parallel lines cut by transversal. So RW, this transversal right here, that's cutting these parallel lines, is going to tell me that that these are congruent. So that angle R and angle W are congruent. So angle SWT, however you want to say it. So by the by the angle-angle similarity, again, I've shown that two angles are congruent. Then these two triangles are going to be congruent. Now, and again, the idea there is try to make sure you match them up based on like the lettering and stuff like that. Congruent angles to congruent angles. All right, here's two more theorems: the side-side-side similarity and the side-angle-side similarity. Okay, so what does those mean? All right, so side-side-side says something like this. All right, are they similar? Okay. So if I look at this, again, I already can say angle R and angle R is congruent to itself. Okay, so based on that, I've got that. But I don't need to worry about that. But I could say PR, if I look at PR to SR, sorry. I was like, what? Okay, so PR to SR. I say 8 over 20. Now, notice what I did here is I tried to take that top triangle and compare it to the bottom triangle. So 8 over 20, notice how the opposite sides kind of went there, are what I'm comparing, and that gives me 2/5. Okay, so then I try, say, the bottom and the top, PQ and ST, I get 6 over 15, which also simplifies to 2/5, and then QR to TR, that's 5 over 12.5, which would simplify to 2/5. I can show you how to do that on the calculator, by the way, because that might be a little bit more difficult for that one on the calculator. But anyways, when I look at this, they all give me the same scale factor. They all gave me the same similarity ratio. So because of that, that means all three sides are similar. So then I can say by the side-side-sides similarity theorem that, say, the two triangles, the PQR, is going to be similar to the STR. And that's it. How about another example? Well, why don't we? There's another example right here. Okay, now this one's a little bit more difficult. Okay, so here, obviously because angle A is congruent to itself, because, well, it's the same. It's the same for the small triangle, which is AEF or AFE, as same as it is for the big triangle, which is ABC. ABC, yeah, that is a B. Don't you all dare think that's a 13, because I know some of y'all are going to say that. Anyways, all right. So now I want to compare AE to, say, AC. Okay, AE is 8. AC is not 4. It is 8 plus 4. Make sure you realize that's the whole triangle, and that's 12, which simplifies to 2/3. AF and AB, AF is 10, and FB is 15. So again, 2/3. So they have the same scale factor. So by the side angle side, because notice that this angle, A, is in between the two sides, then these two are, say, similar. So keep in mind how, like, this left side, I'm trying to get a highlighter here. This left side and this right side keeps this in between. The angle is in between those two sides. That's important too for side, angle, side. Anyways, let's look at some solving. We want to solve. We want to solve. We want to solve. We want to solve. Solve. We want to solve. We want to solve. Anyways, all right. So here we're going to say ba-bam, 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 ba-da, 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 da-da-da-da-da, da-da-da-da-da, da-da-da-da-da. Okay. So how do I find this out? Okay. Well, I'm going to go with the two that this AB and this AC. Okay, those two I know, and I would use those as part of my similarity ratio. Now, I'm going to assume, or it's going to be given that we're saying these two are similar. So that means all these sides should have the same type of ratio. So if I say AB over AC, actually I should have said AC over A. No, I was right, AB over AC. Okay, so that's 3 over 5. Okay, so all other sides have to be in that same similar ratio. So I can set those equal and try to do a cross multiplication. So I can say here BE, which is X, and CD, which is 3.5, and then I can cross multiply and divide. And I would get 2.1. So the X is 2.1. Now, let's say I try to do the next one. The next one's a little bit more difficult. AE, AD, okay. So the next one I would say AB is 3 and AC is 5 again still. And then I could say, okay, AE is Y. What is AD? AD is Y plus the 3. Okay, and then when I cross multiply, that ends up setting me up for one of those variables to the left, numbers to the right type of thing, which would give me 2y equals 9. So y is equal to 9 over 2, or 4.5. And so that would be y, and then if I wanted to add 3, I would find out that AD is 7.5. And that pretty much covers it. So anyways, that kind of covers everything. I do want to go over some more of this in class, like kind of go over some of these problems and make sure you understand, see how it sets up. But otherwise, that's it, guys. Thank you so much for your time. Y'all have a good day.